Hey, we got ourselves a problem where we want to try to apply the conjugate. So I'm just going to copy this thing, but really we're going to want to do a plus in order to get the conjugate. So we're going to multiply top and bottom by that thing. So now what's going to happen on the top is if we think about it in the form a minus b, and the other one as in the form of a plus b, then we have to apply the formula a squared minus b squared. And if I square that a, well, it will just be everything that's underneath the square root. And if I square the b, well, I'll get 49x squared. So what will happen with that is that these guys will cancel. And now I'll just be left with 4x plus 1 on the top. And my bottom is really just whatever I see over here. So I'll put that on the bottom for us. And now we're taking the limit as x goes towards infinity of all of this. So now we just have this. And this one is a particularly tricky one. When you have a limit as x goes towards infinity, you can often get away with just looking at the degree on the top and the bottom. The degree on the top is 1, but it's not really clear what the degree on the bottom is right now. So we have to do a trick that is kind of the proof of that degree trick in case you've seen that before. And the trick here is that we're going to divide everything by x. So every single thing that you see is going to get divided by x. But the thing that's a little bit weird about this is that for the square root thing, we want to, instead of putting x, we want to put x squared square rooted. And then we want to change these two square roots into just a single square root, and then we'll put our 49x squared plus 4x plus 1 over our x squared. And then we're going to change that one more time, so that way it is really square root of 49 plus 4 over x plus 1 over x squared. And now if we want to complete what's going on the bottom, this would be a 7. And if we want to talk about what's going up top, we would get 4 plus 1 over x. Okay, so now we're taking the limit of this. But now it's finally clear what's going to happen, because as x goes towards infinity, that means that your bottom is getting super big. That means that these fractions, anything that has an x on the bottom, is going to go towards 0. So they're just going to disappear for our purposes, and we're just going to be left with 4 over root 49 plus 7. So that's 4 over 14. If you want a little bit of a shortcut, you could have kind of seen this before. You could have just decided, it's almost like all I had to do was the limit of 4x over root 49x squared plus 7x. These terms right here, the 4x and the 1, they really don't matter. So we can just kind of ignore them. And when I do so, I would have gotten 4x over 7x plus 7x, which is 4x over 14x. And then you can apply that same trick that you might have seen before when the degrees are the same on top and bottom, which they are in this case. They're both 1. And then that 4 over 14, well, that turns out to be what our answer is. All right, challenging limit problem. Take care.